Hi everybody, this is Aaron Murakami, and I'd like to welcome you all to the call. This is the live Q&A session that I have set up with Jim Murray and Paul Babcock. The reason if you received an invitation to this call, it's because you, in the last couple months, have purchased a copy of the presentation from the recent 2014 Energy Science and Technology Conference. And the title of the presentation is The Secrets of Tesla's Power Magnification. And at the conference, not only did Paul and Jim give a co-presentation on that subject, but they also had a demonstration of Jim's SERPS technology using Paul Babcock's switching technology. And at the conference, what everybody was able to see was a demo where 50 watts of light bulbs were being lit up to full brightness, yet there was only 1 net watt of power drawn from the power supply. So that doesn't mean 1 watt is lighting 50 watts of bulbs. It means by the time you take some energy and give it back, the net that was taken from the power supply is 1 watt. So there is a difference. And first of all, I'd like to thank Paul and Jim for being on the call with us tonight. They've been putting in a lot of long hours working every day on their own developments with some of this technology, and so coming to the end of a workday, it's kind of late for them. So I'd like to thank them for taking time out of their schedule to be able to be on this call and answer some questions. And before we take some questions live from the audience, there's a couple things we'd like to go over, and I'd just like to mention, if you can go ahead and mute out your phones, and then here in just a bit I'll go ahead and open up for questions. So one of the first things I'd like to mention is that, Jim, you had something to say about the kind of the patent situation, and there's a lot of people, asking very specific questions about the circuitry, and so if you'd like to go ahead and start off by addressing that.
Yeah, sure. Basically what the message is that I want to deliver is a very simple one. We have been working on this for many years. Paul and I were, of course, doing separate things and came together only about 2 years ago, but now we're working together to get this thing to the point where it's going to be commercialized. And so one of the first things that's necessary in that regard is to file for patents, and we have done this. And the fact that we made a superficial disclosure during the energy conference is going to present us with enough difficulties in getting around the patent office, who is always trying to stymie these things. And so it would be a great help to us if you'd be patient and understanding about the fact that we can't reveal everything that'll make this thing work at this point in time. However, you should also be encouraged about the fact that ultimately this will be in the public domain. We have no intentions of keeping it a secret. We just would be very grateful if you wouldn't start passing information all over the internet about this thing, because it's going to be a difficult thing to get a patent granted on a subject as obtuse as this one to begin with. And if you muddy the waters by circulating all kinds of theories about how it works and how it doesn't work, that makes our job a lot more difficult. But I do encourage you to continue your personal investigations. Just keep a lot of what you're doing to yourselves, and eventually it'll all be vindicated, because I guarantee you this device is real.
Okay. Now there's asked a few people to go ahead and post some questions in Energetic Forum in the thread that I started when I released that first demonstration video showing the 20 times more on the SERPS demo. That's when you're heating up those inductive resistors, showing about 100 watts for only a few watts being drawn from it. And obviously anything like this, there's going to be a lot of skeptics coming out of the woodwork and trying to debunk everything, even though they have no idea what their circuitry actually is. And but thankfully, there are some people that obviously they see the possibility here. And from what they learned from the presentation, in principle, everything you guys are talking about makes sense. And so there are a couple questions here that I just want to cover from somebody named Mario. He's in I believe he's in Switzerland or something like that, wasn't able to join the call. So I'd like to at least answer his questions that he posted in the forum. And then I guess after that we can go ahead and open up for some live questions.
Sure, whatever you want.
Okay. So for Mario, let's see, he posted this on, looks like fairly recently. One of them was today. Okay. So thanks for the opportunity to dig deeper into this. Since the release of the video, I've been working on this quite a lot. First, an audio amp as a source, then with a motor-driven generator that has the magnets north only facing the coils, which still gives an almost perfect sine wave. This may or may not be ideal. I just got a 1 kW 3-phase neodymium wind generator to make further tests on, but the 3 coils are star connected and I can't access the neutral. Should the SERPS effect still work if applied between 2 phases as a source, which gives me a sine wave, which is the result of the vector sum of the 2 sine waves? Or do I have to have access to 1 coil terminal to do the switching on? That's one part of it. Do you want to answer that?
Yeah, I'll take a stab at that for you. First of all, the best advice I could give this gentleman would be to concentrate on using a transformer as a source initially. It's a lot more difficult to achieve this effect than what you think, and to do it, you know, in an effective manner. Secondly, when it comes to generators, there's going to be a very complicated arrangement necessary to access this on 3-phase. If he's got a 3-phase machine, he's going to have his hands full. I'm not prepared to talk about the 3-phase stuff because we've only now entered into single-phase patenting. But I will tell you this, in the long run, to depart from the norm in generator design by having some kind of an unusual arrangement with all north poles, that's going to make your job a lot more difficult. If I was doing it, I would start with a very traditional machine. We'll leave it at that.
Another thing is if you're dealing with European power, the difference between European power and American power is you don't have neutral 120, 240. All the power is the same. You really need to work with a center tap secondary transformer to get started. You know, it's part of the trick to putting the power back. And so if you have a 50 cycle transformer that's single phase that you can plug into the 230 or 240 and then voltage and get a center tap split phase secondary output, that's what you really need to develop your circuitry.
Another part of this question is, I have more questions regarding the switching timing, which I'll post, but this is the most urgent one for me to advance since I'm putting the new setup together. I guess you kind of already addressed this. If you tell me 2 phases won't work, that'll save me some time, and I'll try to locate a single phase generator. I suppose it has to be a generator with magnets though, correct? So
It's
actually easier the other way, to be honest.
yeah. The thing about your generator is it's got to have a quality sine wave.
Okay.
Don't go buy a cheap Chinese generator, it'll break your heart.
And you've already answered pretty much, start with the transformer, not the generator, because it's going to be a lot easier to go that route. Let's see. Now he's asking some specifics on the circuits, and as you've already mentioned with the patent, there's only so much you can say right now until that's published. But where exactly do you switch with respect to the source sine wave?
That's proprietary, we're not going there.
Okay. Let's see. If we were to mimic a tank circuit with a load in series between cap and coil, we could only have some success if the source voltage would be very high and the impedance resistance of the load would be very low. I imagine this concept to be true for the SERPS process as well. Is this correct?
He's getting into some sticky territory there because the question itself suggests that he doesn't know the difference between EMF and voltage. A tank circuit is a voltage sensitive device with respect to the voltage drop across the inductance and the capacitance. If he starts doing this in a generator, he's going to have to be in the position to differentiate between the EMF in the generator winding and the voltage in the generator winding. And there are no known instruments that do this. And so the way I conquered it was by building my own instruments. And I'm not about to go into a 2-hour lecture on how to do that, so he's just going to have to be patient.
Okay.
Yeah, well, the other thing is you have to think about electricity different. This is not resonance. It is in a way, but it's really, because the switching is what we call pure switching, you know, it duplicates mechanical switching. You're really interrupting any resonance. You've divided your sine wave up into, really what you're doing is charging and discharging in DC form out of AC waves. So it's not, you can't think of it in terms of resonant as standard resonance. It will drive you crazy if you do so.
It's actually the type of resonance that they find in a cyclotron. It's called temporal resonance. And even though there's elements of impedance matching and the use of tank circuits involved in the overall picture, it doesn't come together the same way. So in that regard, Paul is absolutely correct, and you should take note of that.
From experiments, an audio amp or an inverter as a source can't recycle the energy that's sent back, as opposed to a mechanical generator with moving magnets. In your opinion, can this be done with a solid state source?
Inverters are, you know, it's a great way to burn up an inverter, because you know, when you use a transformer, you're actually sending that power back to the grid. It's very hard to measure because of how the grid works, because you have this massive 0 ohm load out there. But on a generator, what you're trying to do is create motive force, not drag force, to cancel out the drag force. You know, you have Lenz's law in a generator. The more current you draw, the more horsepower you have to expend to overcome the drag in the generator. So what you're really doing is you're taking power out, you're making it work, you're storing it, and then you're putting it right back in at the right point that forces that generator to turn into a motor, but you're still making work both directions. So you're trying to reduce drag force on your prime mover while you're creating work at the same time. And that's the mathematical inequality. And so that's the trick to the timing. And your switching has to be clean. You have to basically duplicate mechanical switching. When you're putting just standard transistors in there with the bypass diodes and all that, you get sneak paths through and forth, and that's why if you go look at the flyback patents that are published, you can see some of our architectures that will allow you to do that.
Okay. And I can maybe post some links, I don't know, since they're in a bad database.
Yeah.
Pretty much everybody can look them up.
Yeah, you know, and that's public knowledge, and you know, anybody can look up our patents. They've been out there for years, so I wouldn't tell anybody that that's how we do our switching. It's a big dark secret anymore.
Okay. Now, in terms of, you know, thinking about electricity different, you know, I get a lot of feedback from a lot of people, positive and negative, and, you know, there's always somebody trying to debunk something that, you know, that they're not even really qualified to discuss, but,
Yeah, well,
which is, you know, pretty common, but one, you know, probably the most common one is, well, if you're taking the energy from the transformer and if you're able to power an incandescent bulb with it, how can there be anything left to be able to charge a cap and feed it back?
that's the magic of the switching.
And that seems to be the most common thing, and you kind of mentioned one analogy, Jim, to,
Yeah, well, there's a very old demonstration in physics where they use a thing called a ballistic pendulum. But rather than get into the complexities of that, I'll just simplify it even more and talk about firing a high-powered rifle into a tree. If the bullet doesn't come out the other side, it means it's surrendered all of its energy to the tree. If it goes through the tree and keeps on going, that means it had more kinetic energy that wasn't removed from the bullet. And that's exactly what happens in an electrical circuit. If you pass a current through a resistive element and the current keeps flowing, what does that tell you? If this person's theory was correct about there not being any energy left, then not only would the light go out, but your current would stop flowing for a period of time until you reverse the cycle, and that certainly isn't what happens.
So it's kind of like an electrical version of mass moving with inertia. Is
Well,
that similar?
you hit a very interesting parallel there, because one of the things that has not come down to us through electrical physics was the work done by Tesla in this regard, and he talked about the great importance associated with electrical momentum. And that was explored by Einstein and de Haas back in the 20s, and they came to the conclusion that there were aspects of Maxwell's equations which did not identify the component of energy associated with mechanical motion of the conductors. I mean the conductive particles. And so that's been left out and it's never been fixed. And that's only part of it, but you know, there's plenty of room for the effect. Just keep in mind that if it was really against nature, we wouldn't be doing it.
Right.
Well, and that everything we do is no laws of electrical physics. We haven't changed a thing. We haven't created any new formulas, new known ways that electricity works. We just took electrical switching to make electricity work multiple times. You know, instead of letting that electricity rotate around just through the, you know, one terminal through the load back to the other, we
Interrupt the process.
interrupt the process and capture a charge and then make that, and where we got work out of that charge once, well then we turn around through the switching process and make it work through the load again while it creates a cancellation force within the supply. You always have to know that it took magnimotive force to make electricity. You know, and that's the deal. When you're tied to the grid, there's some spinning mass out there that's translating mechanical force, you know, in relationship to Lenz's law. Well, it's another sneaky way of eating Lenz's law. Lenz is not set in stone. Lenz is not, the only way it's tied to Newton's third law is if you make it that way. You can beat that with electricity. And that's what the switching process does. You're literally making electricity work twice instead of letting it work once and then go back to the source. So it's all about the switching and the timing. And it's like what we've done with our motor designs that we just received our patents on. We figured out how to couple in space so we didn't get drag motion induced into the armature. We build up a charge in that inductor that makes magnetism that flings that magnet around. And then when you collapse that charge, we get it all back, or most of it back. And then we put it right back in again. So if you watch the video that's at the end, where what we're doing is we're switching the power out of those coils to a resistors, and we're burning a bunch of, you know, and you'll see the amperage about 11 amps or so. And the resistors are getting hot, that power is going into the coil and back out of the coil and heating the resistor while we're making motion. So, and theoretically, that's supposed to be impossible. Then when we take that electricity in the resistors, you watch us while we're switching that back, we actually put that electricity, recirculated it right back in and used it again. We didn't pull it from the source, we reused it, and you watch the amperage drop to half, to 50%. And actually, you know, the power and the load didn't change a bit. So you can use electricity multiple times. We've been doing it for years. It's just a fact of physics, and that's the way it is. We don't even argue with people about it anymore because we do it every day. We commercialize products with it, and it's just how it works.
And your the patent on your motor, and that's published.
Yeah,
in the last year or something.
Yeah, we just received that patent, yeah. And it's all about, it's the same switching we're doing with this. It's all about interrupting the electrical flow, capturing the stored energy and making it work all over again.
Right. Yeah, so if you all search the patent database for Flyback Energy Company as the assignee, then you know, you're going to see a lot of these patents. You know, that's behind some of the videos and stuff that Paul showed at the conference.
And as a continuation to that idea, I'd just like to throw in this. Years ago, when I was working for Bethlehem Steel, I came to an understanding of some of this stuff in a much deeper way due to the enormous amounts of power I was responsible for managing. And from that information came the discovery of the Dynaflux alternator, which has also been published in numerous places, and it's also in the public domain. The interesting thing that comes from all of this is the realization that the limiting factor in our electromechanical physics of magnetism and electricity resides in the fact that all motors are generators and all generators are motors. And the reason why you have limitations in their functionality is because of this dual character that they have. Every time you're running a motor, it's generating a voltage, and that voltage works against you. Anytime you're running a generator, it's running as a motor, and that torque is working against you. So I spent many years splitting the process in half, and I've learned how to build generators that don't motor and motors that don't generate. The problem is that they're so bloody expensive to perfect, and investors are so darn impatient, we'll leave it at that and be charitable, that work was never terminated. But the interesting thing was, I came to such a deeper understanding from building all that stuff that I realized, hey, we can take the same limited technology that nobody wants to change, and by playing the right games on the far end, by manipulating the power electronically, we can achieve effects which are almost identical. And that still leaves the door wide open for all the other possible changes that we'd like to bring out, and God willing, we will.
Okay. Anything else you want to cover before we open up for
I'm ready.
questions?
I'm ready to.
Okay. Well, if anybody has a question, go ahead and go for it.
Yeah, I have the question. My name's Barry. I'm in the UK, so excuse me, it's a little bit late here. I have a switching scheme that does use a center transformer, and I've managed to get certainly pretty much the same power return as going forward through the load. So I've replicated the waveforms that you've shown in your presentation. However, the difficulty that I seem to have is getting enough volt drop across the load to develop any meaningful power actually in the load. So, you know, when I look at it, when I measure with the digital, and this is with a 4-channel digital scope, when I'm measuring power through the load, it's always less than the differential between the forward power and the return power that I'm achieving. I'm wondering whether you could give any tip or hint that might progress that a bit further, because I hit like a sticking point on this now.
Well, I would love to give you the answer to that, but I think that at this point it would be premature simply because we haven't even finished with the patent filing, and that issue is not only pivotal, but it's addressed in our patent application. The best thing I can tell you is to just think about the exact problem that you just got through outlining and realize that there is a solution to it if you're clever enough about how you manipulate all of the forces that you have at your disposal. That's what I did, and I finally saw the light. And there's no real trickery involved. There's just a basic understanding of what you need to do and how you need to do it. And I don't mean to be so cryptic, but I have to be on account of the legalities involved. Just take my word for it. It's a soluble problem.
In fact, it's what we've been testing all day today, exactly that issue you brought up. And time constant is critical to function. That's the hint I'll give you.
Okay, thank you.
One comment on that, though, I'm very glad to hear that you're pursuing this, and it's a shame that the way the world is structured and run by people that have other objectives, makes it so difficult for people like us to corroborate. But it would certainly be nice if there was a way that we could all put our minds together and change this bloody planet before it's too late to do so.
Mhm.
Do you have any other questions, Barry, or?
I've probably none that I feel that you could answer. Yeah, I've got to a point in the development where I've tried many schemes, but as I said, I ended up with using a center transformer, and essentially I determined a way to achieve the right impedance for the return power to be achieved, so I could actually balance the waveforms. That took quite a bit to get to that point where I've got pretty much the same current going forward as the same current going back. Also, I did realise it's not just a case of where you discharge the cap in terms, but it's not just the current you develop, it's also the voltage that's got to be present there as well to develop the actual power. So it is actually possible to push more current back, more return current and forward current, but still not develop the power. So that, I can understand that the timing is critical. But I've got to that point, it's just, what I'm developing with the load is very, very low, and I'm struggling with that problem.
Yeah, I understand exactly where you're at.
Yeah.
We've come from 50 watts to about 1,000 watts right now out of exactly the same prototype by conquering that exact problem. And I wished I could tell you, I really do, right at the moment. You'll just have to be patient with us here. When we get our word from our patent attorney, we won't have too much problem spreading some of the secrets around. But you're on the right path. You're getting there. Just think about RC time constants and where you put it back.
Yeah, and also another little hint I can give you that won't disclose anything except maybe get your wheels turning a little. And just realize that RC time constants are a percentage, and the way they're normally taught is not necessarily the way they actually operate in this circuit. That's not to say that you don't use those values, it just means that you don't want to necessarily optimize them the way they're suggested.
Okay. In your presentation, you did mention that back at that time, that the next stage for you was to try, the test circuit you developed with an actual generator to see whether, it held water with the generator. Have you managed to accomplish that successfully? Do you have it working with a generator now?
We have had really good success with a small generator, and then we moved to a larger one, and unfortunately it was built in China, and the waveform was so bad, and there were so many harmonics that it just about destroyed the effort. So we put that on the shelf until we can get a really good machine for the time being.
But yes, we did. We made the generator speed up significantly when we got it. That's why I highly recommend getting your circuits developed on a transformer first. And when we went to the generator, we found out you really have to be able to track the cycles closely. You have to have a really clean sine wave. When we got the timing right and we drove it right back into the generator, it picked up RPM significantly, which is the indication that you are doing. If you're dragging it down, you're using more power. If you're making it go faster, you're producing the effect. But then when we speed up, it would throw our timing out on our sense circuits, and then they would get all confused, so the thing bounced back and forth, but the effect was obvious. So we're upgrading our sensing and zero cross, sensors. So
yeah, I have a lot of trouble with the zero cross circuit picking up transients from the actual switching. So at the moment, I'm using a transformer, but with a power amp driving the primary of the transformer, and then I've got a twin that I'm using to drive the power amp. The other one I'm using to drive the zero cross circuit, so it's completely isolated from the switching.
Very good,
So
yeah.
but that's still a problem to be solved on, you know, if it's going to work with the generator, it'll have to work off of the zero cross circuit will have to work off of the sine out of the generator, and I still see that as being a problem.
It will be, believe me.
Switching, anytime you're using switching inductors with transistors, the noise you generate is your worst curse. Because so on your sensing circuit, pi filters, incoming pi filters help a whole lot. But what happens with transistors, and most engineers don't really understand this, when you're doing clean switching, when you're duplicating mechanical type switching where you don't have those bypasses to run the flyback energy by your switching device, what happens is you get high frequency noise. If you have a spike, the harmonics to that thing can run up to very high frequencies, and it just goes right through the inner electrode capacitance on your transistor, and it just walks right in and kills the junction barriers between your gates and your other elements of the transistor. And then guess what happens? It turns on, and it'll turn on all of them at the same time, and then you have, then the smoke gets away and the ghost gets away and start over. So conquering noise issues is number one to get into the power level.
Yeah, I've certainly already gone through, well, I've gone through MOSFETs and I've gone through IGBTs as well. Even with them connected, conventionally protected, it still is an issue. And one of the problems is, of course, if you're switching for something that's approaching, 4 or 5 milliseconds, seems to be the safe operating curve. A lot of these devices, single devices, is going to be a problem. For test purposes, I've got around that by using pulse width modulation to limit the duty cycle so they can handle the current. And that seems to have got me through a test phase where I'm not taking out so many devices. But it has been hard to actually determine whether it's an overvoltage transient taking some of them out, or whether it's another current transient taking them outside their SOA and taking out the device. But I've hit a plateau where I've got a technique where at least I can pursue it further.
It's what gets you is the actual inductor itself is what's getting you. And that's why we spent, I'd say that in the last 14 years, we've probably blown up 20,000 transistors easily, conquering that problem as we moved up to bigger and bigger inductors. And that's why our flyback technology, that's why high frequency switch mode technology came along, because you got about 3 loops of wire that don't throw all that energy back at you. And that's the failing of transistors. They don't handle that high frequency generated noise off of, spiked voltage off of the big inductors. And the bigger the inductor and the higher the current, the more it is. It sneaks right through the inner electrode capacitance. It's just like, you have to look at a transistor. It's not just on and off. It's also an RC parallel system. So even when it's completely off, it has a C value. And that's what gets you right there, because that just lets that high frequency energy in. It's at extremely high voltages. When it sneaks in and gets inside your transistor, it affects the junctions. The junctions turn on or evaporate. Your transistor suddenly becomes a piece of wire, and when you got 8 transistors out there in an array and they all turn on at the same time, it's disaster. And we spent years conquering that problem. And you'll see a bunch of that, how to deal with that in our patents. It's something we don't...
I did try an SCR in series with IGBT, and certainly the SCR, will survive anything. And turning the IGBT on first and then firing the SCR. But I'm still taking out IGBTs, of which I still haven't got to the bottom of that, because with it turned on, it should handle its full rated current. So it was something still taking out that IGBT.
Yeah, and it happens right when you turn it off. When you turn that IGBT off, and you see that big spike come off your transformer there, that's your enemy. And so if you put like a pi filter in front of it, works. There's other active stuff we've done that fixes it completely. And sometimes you can even use series parallel neon bulbs, you know, that are just, if you take neon bulbs and you series and parallel them out, right up to where you're just above, you know, maybe 40, 50 volts above the peak current or the peak voltage of your AC source so they don't turn on. When that source, when that flyback energy comes on, it'll turn that neon on and absorb all that energy before it gets into your transistor. So you put that neon pack, and it's a pretty handy tool to save your transistors. It's a little clunky, but it does work really well. If you look on the video,
well, that's useful.
Yeah, if you look on the video or motor, you see all those flashing neon lights. That's exactly what it's doing. And if you disconnect one of those neon packs, that switch is dead instantly. Those are like 300 millihenry coil elements in that motor. So, and if you parallel them out, like they're about 70 to 90 volts depending on the neon you buy, so you just series them out. So if you're like if you got 230 volts, your peak is about something like 300 volts. So you series those 70 volts out to you're like at about 350 or 360 volts. And then you parallel those series strings out to handle the power that's coming out of your flyback. And if they're flashing, they're saving your transistor, and you'll find you can do a lot more power that way.
So with your experimental setup that you showed in the presentation, the one that you showed the waveforms for, was that using purely capacitors as a storage medium, or were you using inductors in that setup?
It's purely capacitive.
Yeah,
The waveforms seem to indicate that, but I thought I would ask.
there were some differences between what we did there and what we're doing now, because the electronics that I was using for the controls were nowhere near the precision and the flexibility that we've now achieved with Paul's help. And so we did some things in that other arrangement, which was one of the early machines, in order to move the, I don't know what you want to call it, we used to call it the energy neutral, to move the energy neutral point around. And in doing that, that allowed us to change the timing, which we do in a couple of instances there to show how you can change the amount of power that's being reflected. But all of that has been done away with because it was much too cumbersome.
Are there any other questions, or do you have any questions, Barry, or does anybody else have any questions for Paul or Jim?
Well, I think I've certainly got enough there for me to maybe progress a bit further, particularly on the, I'm having nothing go on the SCR and IGBT arrangement, because what I can see is that's probably the only way to get the power up. Trying to do it purely with MOSFETs or with IGBTs, I think is just going to be a road to failure. It's got to involve SCRs in that, as far as I can say.
Think in terms of mechanical switching. See, that SCR FET arrangement is the only thing that really duplicates mechanical switching characteristics. A FET or IGBT by itself is really not a true switch, because when it's off, if you have a polarity reversal, it turns on. And it's also really susceptible to interelectrode noise. But the SCR is a true switch. When it's off, polarity reversals don't matter. The only problem is you can't turn it off once it's on. And the only purpose of the IGBT or the FET is to turn that SCR off. So the trick is when you're generating that noise, you don't want it turning the other switches on in the circuit, and that's what really gets you. is that noise, it'll turn the SCRs on too, and it'll turn everything on. So that's what, that inductive noise that's generated, that nasty spike that you can see go to 1,000 volts. And the narrower it is and the taller it is, the worse the effect, because the harmonics related to those spikes is extremely high frequency, which makes it easy to get into small capacitance. So that's why you have to deal with that. You have to chop that thing down, give it a place to go. And we do it with our flyback technology and our devices, our inverters and our lighting controllers. We do it actively. But the problem with this is you're doing it off the source supply. So try the neon lights, pi filters between your transformer and your switching will help a bunch. If you can knock that spike down to a low, if you put some big pi filters in there, it'll knock that high frequency spike down to a low frequency ring, and then you're safe. You know.
Okay.
So what happens in the conference? Do you try to sell boxes?
Do you mean sell like finished models where people can buy? The future, well, they're currently in the process of patenting it, and so it's kind of a ways off before anything like this is going to be able to just be, you know, purchased on a website and used, but
it's a ways down the road. Commercialization is a very bloody, painful process, expensive process. And, you know, we have a kit concept we're working on clear up to commercial applications, so it will come. It's just right now our total focus is on patents and intellectual property protection, which wouldn't even be that big a deal, except that, you know, when you take investors' money, you better very well, you know, toe the line, you know. So we have legal issues we deal with and ethical issues, and we maintain ethics at all times. So you know, development money's hard to come by, and we have to respect people's investments. So that's why the patent issues are so important, and we can only reveal so much.
okay. Now I'm seeing on the call screen here that there's go ahead. And if you could speak up a little louder, sir.
You already fixed the problem? Yeah, this is Stefan from overhumanity.com. Did you already fix the problem that your SERPS device is putting out a lot of reactive power onto the line bank?
Well, it's not a waveform that utility companies are really happy with. We send the power right back to the grid. It loads up on you, but you have to think in power factor and reactive power in a completely different way. It's a form of reactive power that actually is power, rather than reactive power that isn't real true power. So everything is in phase. You know, it goes out there, it raises the voltage on the outgoing power actually loads up. It's just like a solar power inverter driving power right back on the grid. It's just at a multiple of your source frequency, and so it's not a waveform your local power company is going to be really happy with. But it doesn't matter, you know. So, and utility meters don't read backwards either, so it's one of those things. You are sending power back, and it does go out and load up on the load out there on the grid. And so you have to, there's so many things with this that you have to literally think about electricity in different terms than we're all trained to do. It is a form of reactive power, but it is true power. It does work.
And
That's the reason why I termed it reactive
Yeah,
watts.
sure, but can you use another device before it to make the power factor 1? So the line doesn't see reactive power?
Well, see, that's the problem is everybody, your power meter out there that your power company is using on your meter uses the power triangle. So when it gets all that negative current in there, it just applies the power triangle to something the power triangle doesn't apply to. So it's really totally miscalculated by the meters because they're not programmed or don't have the right mathematics in it to actually measure what's going on. So if you have a way to, if you use the right math and know what the phenomenon really is, it's easy to calculate. But it's anathema to the 100 years of grid maintenance and grid technology to where the power triangle is the determining mathematics to power measurement. The power triangle doesn't really apply. So when your meter reads it, it gets it all wrong. So that's why it shows when you're doing it right, you actually get a power factor of 0 rather than 1, which drives your utility company crazy, but, they would say that you're taking in power and sending it all back. And
what I mean, the power companies don't like that you have power factor of 0, so they have to drive it back and forth. It's only cycling back and forth the reactive power. They don't like that.
Yeah, well, and that's what they don't get. That's where their meters are actually lying, and they don't like people who pull in current and send it back. They're especially not going to like people who pull in current, use it, and get work out of it and send it all back to them. So that's why we're really focused on generators, and there's ways around that which we can't talk about right now, but having spent years dealing with utility companies and utility engineers, they have a way of thinking that's just, oftentimes anathema to logic. But, so basically, utility companies are like this. They're stockholder-driven companies, and no matter what they tell you, they don't want the rates to go down or the meters to spin slower. They want to make money, and that means making sure that you use lots of power and that they get to raise the rates all the time. And, so when you make the meter spin lower or you provide your own power, that makes them not so happy. So really what you're doing with the utility company with this process is you're taking their power out, you're making it work twice, and then you're giving it back to them. And so, in reality...
Right, but then there's the problem that if too many people are using your SERPS devices, they just have to generate so much reactive power that they really don't selling any active power anymore. So they would not like your SERPS device. Absolutely
they won't. That's why we don't, other than experimenting on transformers, we're really not going there. That's why it's so much more effective to use it on a generator. And there's ways to make generators, all kinds of ways to make generators, and there's all kinds of solutions. And we're just kind of keeping a lot of them close to our chest till we've actually developed them and experimented with them, because my deal is I like to talk from fact and not theory. I can look at something, design something, and think it's going to work and know it's going to work, but until I do it and build the prototype, analyze it, study it, I don't like to make claims. So that's why this is a whole new field. It's a huge field. There's just a whole different way of looking at electricity, and there's lots and lots of work to be done yet. It's just, the more we look at it, the bigger a subject it becomes. The more we know what we don't know. And it's just an incredible exploration. It's just an amazing thing. And it's going to take some time to fully define the science and to take it to where it needs to go. And we're just at the beginning, so this is the fun part.
Have you already tried to go from 60 hertz to higher frequencies to try to get a pellet loop system? If you go to higher frequency, the storage you should be able to use less capacity, so it's maybe easier to cycle back and forth in reactive power, and then maybe you can also get a self-runner
That's all possible. We just haven't had the time, you know, and so we got a certain amount of resources and a certain amount of bodies, and we've actually only really been working on this for less than a year. So, I mean, I met Jim in the energy conference before last. 6 or 8 months went by. You know, we talked about it, went down to his lab and studied his prototypes. Then I spent the next winter from January till about April building prototypes, blowing up transistors, you know, going through the painful process. And we were able to produce the 50 watt machine that we were for the demonstration. So, you know, so there hasn't, you know, so we've been working at it hard, but it's just at the beginning. There's just huge amounts of things to do yet. And so right now we've gone from 50 watts to about 1,000 watts, working out the bugs, working out the troubles, and defining the science. And so really Jim's concept is about 35 years old, but the real hard work on it we haven't even completed a year yet of the real hard work. And there's just 2 of us. So, plus we have jobs and work to, you know, we have companies to run and things to do in the meantime too. So, you know, so we've come a long way fast. That's why you guys got to be patient, you know. We're just in the beginning. And you give us another year, you'll be astounded. So the answer to your question is no, we haven't gone past 60 hertz yet because we haven't got all that done. But yes, we can go to higher frequencies if we can create the switching circuits that can keep up with the higher frequencies. As you go up in frequency, and you know, there's lots of effects. So, you know, but right now we're seeing that we can make commercially viable.
What happened to your motor? You have shown your what is it called?
Our space coupled motor. That's one of our next projects. That's actually that's one of the first things we built. We started on that 14 years ago, and it's the last thing we got patented. But that's one of our goals, is to build the next one. And it's a very complex machine. Building it was one thing, making it work was the other, but now we have so much more experience with our electronics, we're so much more sophisticated with digital technology. The next one will rock the world. It's just I need $1 million, $1.5 million bucks to pull it off, and right now we're busy making the company grow, and so it's a matter of priorities. If I had lots of millions of dollars laying around and all kinds of help, we could take on more. But you know, business is business, and that's one of the drawbacks. Is when you're doing this kind of research, it takes funding, and funding is the hardest thing to come up with there is. And if you take people's, you know, so we went the route of building a company with stockholders, and our obligation to our stockholders come first, and that's just how the law works. And so our commercial development comes first, and the R&D comes second, which breaks my heart, but that's just the brutal reality of business. But hopefully here, we get in a better position, then we can take on more of the R&D and take our prototypes to the commercial levels, because the motor prototype, it sits in my lab at my home, and it's just an amazing thing to watch the thing run. It just proved every concept we ever did. I can't tell you how many physicists have ran out the door when they see that thing. They can't argue with us. We have the physics to it. There's nothing esoteric. We didn't create any new formulas, new laws. We used everything that's on the books to build that thing. And, you know, there's just a few basics. Is electricity can be used multiple times, and Lenz's law is not immutable. It can be beaten.
Now thanks Stefan. Does anybody else have any questions? I see that there's a few people that pushed the 5-star sign. Let's see, I'm going to go ahead and unmute this.
I have a question when the time comes.
Yeah, go ahead. What is your name?
My name is Corin. I'm from Texas. My question is related to the relationship between the SERPS device and the power grid. If the power grid fails, what happens to the SERPS?
It depends how it's used. If it's connected to the power grid, it will fail with everything else. But if it's connected to some of the things we're anticipating in the future, then it'll behave very differently. And that's completely dependent upon how far we can take this R&D before there's problems with the grid.
You have to have a spinning magnemotive force to really make the SERP shine. That's why inverters don't work so well. I can't drive the power back into the inverter because I'm not converting mechanical force to electrical force. With an inverter, I'm taking DC electricity and converting it to AC electricity. So I don't have any force cancellation that I can work with. It's all about, power generation is about prime mover force and Lenz's law. The more current I draw, the more opposing magnetic strength I get against my source, prime mover, and that means, it's like Jim was talking about earlier, a generator is a motor and a motor is a generator. So really what we're doing is we're exploiting that relationship to cancel out the drag force.
See, what I did as a younger man was I realized the dichotomy of that technology is actually a problem. Most people think that that's just the way it is. And so I went about and spent 30 some odd years learning how to split them apart so that you could have motor effects without a generator effect and a generator effect without a motor effect. Well, once you understand that in great detail and how to manage it, then there's another option that you have, and that is that you can time share if you want, and use the generator aspect for one period of time and the motor aspect for another. And that's what the SERPS actually allows you to do. And so it's really a complicated picture from the overall point of view, but technologically, with the right electronic assistance, it's very manageable. Somebody had asked a question earlier regarding what would happen if everybody in the country had a SERPS. And actually the answer is very interesting, because the net effect would be that every power company in the country's fuel bill would go to almost zero. But you see, they're not set up for that kind of an arrangement. And so we can't ever expect them to have a sense of excitation over the fact that you're going to reduce their fuel consumption. They're in the business to sell kilowatts, and they don't want them back. So the stuff we're working on now is a system that allows us to have the best of both worlds without ticking them off. I hope that clarifies things for you a little bit.
Yeah, and the separation of Jim's point about a motor is a generator, generator is a motor, and separating those two aspects. That's what our space-coupled motor is all about, is it's purely a motor with no generation aspect to it. And, and I'm also recycling the second aspect is to use electricity multiple times, and that's why it takes and blows that 746 watts per horsepower rule out of the water, because you can make motor force, but it doesn't generate back against you. So it's all these concepts are real. Jim's proven it with his his Dynaflux. We've proven it with our motor. We haven't violated the rule of physics 1, because there is no violating those rules. It's just the belief about those rules. That length is immutable and electricity can only be used once. If you can realize electricity can be used multiple times and length isn't immutable, then the world is wide open to you. Tricky going about it.
Okay. you have any more questions, Corn, or does anybody else have a question? Okay, let's see. I'm gonna see if this actually works.
Thanks, appreciate that answer and that information. This is Coy, and I'm from Texas.
Okay.
Thanks.
Okay, thanks for being on the call. Let's see. Okay, I'm trying to unmute somebody that looks like they have their hand raised to answer or ask a question.
Hello?
From.
Hello.
Yeah,
My name is Didier. I'm from France. I send you question, Aaron. Could you ask them if you have them? Because it's nice here, and I would prefer not to speak a long time.
Okay, yeah, I printed it out, so I'll go ahead and ask those right now, okay?
Thank you.
Okay, let's see. Okay, so here's a couple things that get posted on the forum. Okay, could you provide a way for your sponsors to very simply buy shares for your common company? An offer you would reserve only for those who supported you until now by buying your lectures? Can't really get into like offering shares on a company outside of the.
No, the Securities and Exchange
yeah.
laws here are very strict. If you knew what we had to go through to raise money legally by selling stock here, they actually force us, if you're not a multimillionaire, we can't even take your money. If we could raise money from common folks out there on a small scale, we'd gladly do it. So other people could benefit from building the company, but we're totally limited. You have to be what's called an accredited investor, which means you have to have $1 million in assets that is not your paycheck before we can even take anybody in as an investor in our company, and the government makes us do that. If I could raise $10 from all kinds of people out there a piece and give them a piece of stock, I would gladly do it, but I'd get thrown in jail before you could blink an eye. And it's sad but true.
Yeah, the closest thing that comes to that is some of the legitimate crowdfunding sites out there like GoFundMe, Kickstarter, or Indiegogo. And I think in the last, I don't know, one year, 2 years or so, there are different laws that's kind of touching on the subject of allowing people to actually, do crowdfunding campaigns like that and actually offer shares, but that's still kind of a confusing thing that I don't think anybody's really going to see anything along those lines for quite a while. But yeah, for right now, it's off
the table.
The answer is no.
If you knew how much money we spent on lawyers just keeping track of the law to stay compliant with the law over raising funding, it just eats up huge amounts of our funding just to deal with the legalities of it.
And a couple other. Okay, now the other thing you mentioned on the forum. Let's see, if sending back to the grid the reactive watts they make us pay for. Okay, so your question is, what if we put a power transformer like in industry just after the energy meter of the grid company and having the SERPS on the secondary side of the transformer? Wouldn't that be the only net power in terms of active watts, which would be consumed on the primary winding of the power transformer?
Well, that's where the SERPS actually resides, is on the secondary side, but the problem is that you need to have an undetented watt meter. In other words, it has to truly read power in both directions. The new meters that they come out with now are programmed in such a way that they won't do that unless you're an accredited power source, like a solar, with a solar installation or a water wheel or something of that sort. And if you don't have a setup like that, then they turn that part of the meter off. And so even if you had a SERPS, it wouldn't work. It would still do its thing, but you just wouldn't get any credit for returning power.
So the previous interesting what you just have said, Jim, because I'm an artisan electrician. I have my own business, and I can sell solar panels or things like this, and installation with special meters for this. So what you have just said is if we couple the SERPS with such installation, so it could work.
In theory, you could pull power out from the grid through one meter and send it back out to the other meter. And actually get credits for sending power back. It would most definitely read that as power going back out onto the grid.
Yes. Thank you for the information.
Yeah, another thing you should consider, sir, is the fact that if you put this in conjunction with solar installation or some other form of alternative energy production, like a water wheel or any of the other things that people are playing with, like wind power, now it gives you a totally different advantage, because a situation like that would be metered in both directions, and you would be able to exert this as a lever in your favor.
Yes.
Yeah. Now, another question you had is, could you provide kits to buy of your circuitry with the schematics and so on? And again, that's kind of already been answered, that the whole process is, the patent has to be put in place, and then eventually these, these type of things are on the agenda for down the road.
Yeah, we definitely want to provide a kit system for inventors and anybody who wants to take this, and where you can have an electronic, where the electronics, the complex electronics that's the hard part, and then what you hook up to it is actually much more simple. So we're looking to do that to help people out, and that's one of the first things on our agenda. But first, we have to, once we have our patent squared away, we have some of this stuff perfected, then that is going to happen. When exactly, I couldn't make you a promise.
Does that pretty much answer your questions?
Oh yeah, great. Just a note. I would like to say I love you guys, because you have hardworking like decades on this subject for our greatest interest and for the whole world. And I very, very appreciate the work you've done and what you are doing here. And I appreciate too the fact you want to share it. And I understand too you have a legal limitation right now, but I very appreciate, and I just would like to help in any way, and just want you to keep going like this. And I would be very glad if in the future I could help to disseminate your technology in my country.
Well, I would like that very much, and why don't you make it a point sometime to come visit us here in the States, and we'll see where we can take that.
Would be pleasure. Would be my pleasure.
Okay.
Yeah.
Well, thanks for your questions. And did you have any more questions, or can I go ahead and open it up to somebody else?
No, it's okay. Thanks, Aaron, for having
Sure, you're welcome.
this meeting, and thanks again, Paul and Jim, for sharing.
Thank you. Let's see, somebody has a question in the 719 area code. You should be unmuted, and you can ask your question if you haven't already.
Okay, this is Matt up here in Colorado Springs.
Hi, Matt, go ahead.
Yeah, first I just want to thank Jim and Paul and yourself, Aaron, for putting this together. It's quite interesting. There's really something special here going on.
Thank you.
When Paul was doing his presentation and he mentioned he hooked the fluorescent ballast to his generator and was able to change how a typical generator would perform, it really caught my interest, because I had worked with the Thane-Hines stuff, and now lately Bill Alec has a variation of the Thane-Hines bitoroid transformer, and he calls his the split flux transformer. I find interesting with it is that it may possibly have the same concepts going on. Well, I mean, certainly electricity behaves the way Jim says it behaves. And I'm curious if you foresee a mechanism like this that doesn't need the switching, that the geometry, the way the inductors and everything is assembled might actually do the same function.
Absolutely. It's on my list and agenda of things to do. And the thing about that type of transformer is the air gap high impedance transformers do magical things. I've spent, over the last 15 years, I've learned more about that type of transformer technology than I ever thought I would ever know. You know, if you went out in our lab and looked in our lab, you'd see hundreds of HID lights hanging in our lab, you know, and so developing our lighting controllers. But the magical part is the air gap in those type of transformers. And so what you really have with that, and when I first did it, it was a complete accident. And it drove me absolutely crazy trying to figure out what was going on. And I was in the middle of Bush, Alaska with no oscilloscope. I had a certain amount of test equipment because I worked on generators, but I was absolutely befuddled. I just couldn't figure it out, and I had to put it on the back burner, and then as life went on, you know, it stayed on the back burner, and then I met Jim's with the SERPS, and then all of a sudden I realized what those transformers were doing. You know, they were actually creating a Tesla-type SERPS wave that was funneling it right back into the generator and creating the motor effect, as well as the generation effect. And it was astounding how much more power I got out and how much fuel reduction I got out of the generator. And since I have about 10,000 transformers out there of that type, that is most definitely on our list of things to pursue as soon as we find the right generator, because that type of generator I was using now is like as rare as hen then is as rare as hen's teeth now. So when I find the right generator, that is going to be on #1 on our list to get that going. And
I had played with this quite a bit, and because the way Bill Alec does it, he runs it at higher frequency, so you kind of have to use an audio amp. So I set it up, and I said, all right, let's just assume I can get whatever I can get out of this thing, because it has the capability of pushing back to the input as well as getting power out the output. And I would set it basically to a power factor of 0 by tuning it with capacitors and whatnot. And that got me thinking, well, you know, if you can put it side by side with a regular isolation transformer that's got no load on it, you can see the same waveform coming out of the SFC going back to the grid as you can the isolation transformer with no load on it. The only difference is the SFC is pushing stuff out the tail end. And there's definitely something going on with the electromagnetics there, and it's got to be just what Jim's talked about for years.
yeah, it's that motor generator effect. It's being able to, you know, you know, so you get the motor effect to work for you instead of against you. You know, it's all about, you know, it's canceling that rotational forces that are all due to lengths. And it's the same thing. Tesla was doing it. It's what you find out, you have current waveforms that are multiples of your voltage waveform. And that's, if you get them where they fall into the right spot, they drive back against it and cancel out forces, and you get all kinds of effects like that. Like my old Petter generator there, I rebuilt it, and it had, if you look on the in the presentation, if you look closely, it shows you the diagram of exactly what that generator was. You know, split ring excited stator windings. And it would motor up so fast that the governor was slammed shut on it, and it would literally only draw a couple. You know, it took me to get 1,000 watts, it took me $1/4 an hour to run that generator of fuel. My 1,000 watts went up to almost 1,400 watts, and it only took me a cup of fuel. Totally against the books. And it's the same fact about bouncing that current back and forth in the voltage waveform in a multiple of your cycle frequency. And it falls into the right places into the quadrants, and it makes, it makes a motor effect. So it relieved the strain on the generator. Suddenly my generator is producing power and being a motor both at the same time.
There's another thing I'd like to interject too that you should give consideration to, and that is that, most people don't realize it, but there are 2 potential modes for a transformer to exist in. And generally speaking, the way engineers look at a transformer is that it's like a gearbox. You have one ratio on one side and another on the other side, and you can step something up or step it back down. But actually, that's only half the picture. Just like you have a standard motor is both a motor and a generator is both a generator and a motor. A transformer can actually be something else if you allow it to be. And I only know of 2 people, myself and one other guy in the United States. That doesn't mean there aren't others, but I only know of these 2 people that actually made that distinction and learned how to separate the 2 things that are going on in a transformer. And you're absolutely right about the air gap. The air gap is actually the secret to it. And you could potentially do away with the switching, but then you would have to have a dynamic air gap. And Tesla actually learned the secret of that a long time ago by using the field structure to actually modify the dynamics of the air gap as a function of the load. And when you learn how to do that, you'll need a very minimal amount of switching. But I really can't go into that in any great depth because that's something that I really want to work with Paul on in the future. But I do know a guy who has perfected it, and he's chosen to go to the grave with it for whatever reason. And so it still leaves it wide open for other people to make use of. But you're definitely correct about the nature of the air gap. And just remember that under certain conditions, the flux paths have to be able to do something different than what they do normally. And contrary to popular belief, when a transformer is properly loaded, it has no magnetic field. And there again, we're not talking about no magnetic field at all. We're talking about net zero field, which simply means that the ampere turns on the primary are equal and opposite to the ampere turns on the secondary. But the interesting thing about that situation is that when you really understand what that says, it means your electric field has to be has to have a value of twice as great. And so there's ways of making use of that electrostatic magnification. But this is not the time or the place to get into that, but if you persist in the direction you're going, you'll probably find it out for yourself.
Yeah, I was curious. What I have found on the bench is that it's very specific to the load. You have just the right load on there, and the thing really performs magically. Is the SERPS the same way?
If you take the SERPS as an entire circuit, it is very much the same way in the sense that the load and the other parameters have to be operating in exact synchronicity between their natures in order for that load to be maintained. If you go beyond that point, then you'll see the thing fade out very quickly. And as a matter of fact, if you plot that whole phenomenon, you'll see that it has a curve very similar to a resonant peak in a tank circuit, which is one of the reasons why I called it a resonant phenomenon, even though it's not resonant in the exact same way as a standard tank would be. I hope that helps you.
Yeah, that's exactly what I noticed. It's almost like a Q factor. And if you're in that Q factor, or whatever it actually is, it really performs well, but it's a little frustrating that you can't just put any load on it you want. You have to have a certain load, and then it really works well.
We have the same, we have an inverter technology that we patented, so, and we use a high impedance air gap transformer. And with our flyback energy recovery system, we've made the thing about, typically when you're running it, it's 97% efficient, which is a phenomenal. But when we get things just right, the thing will go to 108%. And
that's where you say it actually runs cold when it does that, right?
Oh, it's dead cold, yeah. The more you get closer to that effect, the more cold it runs. It runs really cold as it is. Then when you hit the 108%, and I mean, there was the first time we saw it, we ripped out every power meter we had in the place, which was substantial amounts, and verified it. And then a little bit out of tune, and it goes right back to 97, 96%. But man, when it's just right, it starts to do that air gap starts to pump energy into the system. And I don't totally understand the phenomenon, but I'm getting there.
That's great information, guys. I appreciate it.
Okay. Thanks, Matt. Let's see, we're on it's 8:23, so hour 23 minutes. You'll wrap it up here in about 7 minutes.
Yeah, that sounds good.
Okay, so we're gonna end the call here in about 6 minutes at 8:30 Pacific time. So does anybody else have any questions before we call it?
Can you hear me?
Yeah, who's this?
Hey, this is Mario from Switzerland.
Yeah, hi Mario. I don't know if you were on the call earlier, but I asked, I think I asked most of your questions.
Yes, I was there actually.
Okay.
I made it. I'm sick and it's night, but I'm here. Okay, thank you guys for having me. I just wanted to ask a few more things. Okay, with the SERPS, be it on the line, on the grid, or on the generator, do I need a transformer, or is it supposed to work without it in between?
There's more than one way to design a SERPS circuit. As a matter of fact, there are several ways that I know of. The reason why we have started with the transformer is simply because of the fact that it makes things a whole lot easier in terms of managing the energy that's flowing and the different paths that the current has to take. But ultimately, we would probably like to do away with the transformer, at least one big one. And there are other ways of doing it that don't even require a transformer. But it really depends entirely on the way in which you have decided to address this situation and how well you understand the overall picture. When I first started with this, I was working strictly on the basis of an intuition. And it's taken a lot of years to understand what's really going on. Once you see the thing from the proper perspective, you'll probably find 10, 12 different ways of doing this.
Okay. Yeah, I'm really trying to say the basics. I mean, very simple stuff.
Yeah.
So with the three-phase generator, in the meantime, I managed to access one single phase, actually the single coil to work with, but I still have the generator slowing down. So I just mean with the SERPS connected directly, I mean the switching SERPS connected directly to the generator, I don't really need a transformer in between for it to work. Is this correct?
If you eliminate the transformer in a generator of the type that you described, it will not work with the normal SERPS circuit. You're going to have to put in a whole different approach to the storage of your energy. And that's the reason why Paul and I didn't go that route on the opening of our investigations. But it is possible to do it. It's just that you're going to have a lot more complications in the switching.
You have to,
Okay.
driving the power back to the grid requires you have to have a way to drive the voltage potential above your source power. Otherwise, you can't make it go backwards. And that's one of the tricks to it all. And so
Yeah, in fact,
that's,
one thing I did is, sorry, go ahead.
and so that's why transformers can help you do that. And there's probably, like Jim said, there's many ways to go about this. There will be, before it's all over with, well, there will probably be 50 different ways to do this. Right now, we're just working with what we know, trying to perfect the first approach. We have other approaches on the books, and it'll get better and better, and the best approaches will, the cream rises to the top, as we say here in the United States. So like I say, it's a big subject, and there's many ways to go about it. But if you have a single voltage source, like you need a type of transformer where you can use step-up functions to get things to drive back.
Okay. So in fact, one thing I did was, one single coil, one phase has 2 wires. I just noticed that, so I admitted that when I charge the cap through the load, the wires are put in series. When I drive the power back, they're put in parallel, so that I can even switch, at sine peak, for instance. Is that what you mean?
Yeah, it might very well work, yes. I have to think about it a minute. And
well, it doesn't yet, but I just want to kind of check if I'm in the ballpark. Because the generator still slows down. Maybe it's not the right generator. This is very easy.
The generator quality, we're finding that that's why we develop our circuitry on the grid and on a transformer, because it's stable and it's a quality sine wave. Generators are unruly beasts. They generally they got a lot of harmonics, and a lot of times they have very poor quality sine waves, and the cycle bounces back and forth, and that makes it, you throw in all those complications in the development of your circuitry, and you can't hardly get there because,
Too many variables.
Too many variables, exactly. So if you start on the grid first to get your circuitry and get the concept where you're pulling power in and you're putting power back, then it's time to go to the generator.
One thing too that I would tell you, I've built maybe 6 SERPS units altogether over the years. The very first one was actually tube driven, and it didn't work very well because we were only working in very low amperage range. And then we went to a tube and solid state device that was kind of a hybrid. But what we had the best results with actually was the last unit that I built, which was transistorized, and it had its limitations on account of that, but it also was orchestrated by an embedded processor. And once you have a command of the concept, you're going to find that it's necessary to have something that operates at very high speed, making logic decisions, and can change on the fly what it is doing for you. Because if your system is totally static, you're going to run into some really severe situations, most especially if you have a rotating power source.
Okay. So what I actually started out with a transformer. I used an audio amp and then a transformer. And what I saw was that I was sending back almost the same power I was taking from the source. But you could actually, the amp still had to work harder because it can't manage the energy. Like a magnet.
See, and that's why the grid is actually energy developed by a rotating mass, even though it goes through any series of transformers. That's why you can't really use an inverter for this because you can drive the power back into the inverter, but it's developing, you're actually just converting DC to an AC waveform, so you have no force cancellation. There's nowhere for it to go when you drive back, and that's why it likes to eat inverters, and you can't get accomplished what you need. It's all about that, mechanical force to electrical force. And that's the key, is to cancel out the mechanical forces. It's really hard to, you know, if you're driving back into a DC load, it doesn't do you any good, because you can't really get it to cancel a force. Or get it back into your DC supply.
So, Mario, I don't mean to cut into your questions. It's just a couple minutes after 8:30 right now, and we're going to have to get this wrapped up. Jim and Paul just finished a long work day, and this is actually coming in kind of past getting into dinner time and stuff. And so, but one thing I want to mention is that I'm going to be working on Paul and Jim's personal website, so there's going to be some more information on different stuff coming out there as we have time. And also, whoever's listening to this, if you already have this presentation from the last conference dealing with the reactive watts and the SERPS type concepts, going back to the work of Tesla. But also from the 2012 conference, if anybody listening doesn't have a copy of it, Jim's presentation, Tesla's Hidden Discoveries, that's a presentation that Jim gave that kind of gave a good background of kind of where he came from in his journey, on this path. And it's kind of an amazing story, and he shares, a lot of the work he's done, not only with the electrical side of things, but also mechanical type devices, and kind of gives a history on quite a few different things that most people haven't heard. Also, in 2012 and 2013, Paul did a talk called Magnetic Energy Secrets. There's part 1 and 2, and that gets into a lot of the concepts that Paul has on his motor that you saw the demonstration of, and some of the other things Paul's been involved in. And also, right after the conference, there is a Dynaflux alternator package that has a compilation of all of Jim's patents and patent applications, and has a couple demo videos on the Dynaflux. I think there's 1 or 2 tours in there going through Paul's shop that I don't think they're really posted anywhere else. But that's, if you want to look at, the Dynaflux alternator has been brought up a few times, and that's definitely what you want to get your hands on if you're interested in looking at the Dynaflux technology. And all that stuff is on emediapress.com. But as soon as Jim and Paul's personal websites are up and ready to launch, I'll definitely be announcing those. And so you'll be able to join their mailing lists and look at the different stuff that's going on there. So I guess with that, do you have any final comments or?
Thanks for the interest, man, and keep up the good work. There's nothing like garage labs, Every last thing in the world that's good came out of a garage somewhere. Yeah. Every last industry.
And don't let people tell you you can't do it, because there's no limit to what's possible in our universe, except for those limits you choose to recognize. And I don't recognize any, so you shouldn't either.
And I'm looking at starting to possibly look at the next conference in 2015. We haven't 100% committed whether we're going to do it or not, but we're getting a lot of email from people that they do want us to do it. So if you're on the conference mailing list, I'm just looking at a couple different date possibilities. And so look out for those emails, because I'm asking everybody to vote on which date they want. The weekend we have been using is the one same day as the Ironman triathlon, so it was hard to get hotels booked and stuff. So anyway, that's in development, and I guess other than that, we can look at possibly doing some more of these calls like this on different topics, and some of the other subjects and the other presentations.
And as we can, we will be helping people out more. We really want to get to that place where we can hand people an electronics kit that they can take and they can hook up to their generators in the wall or whatever they got, and have a sophisticated enough circuitry to where they can get something to work. We're learning lessons every day with this, and we've come a long way quick, and we've got a goal to get some things finished up here in the next month or two, and you know, like today was a huge learning experience. Last week was a bunch of dead transistors, so.
Okay. All right, well, thank you, Jim and Paul, and thanks for being on the call, everybody. Appreciate it. I know it's on the other side of the world for some of you, so thanks for calling in and being part of the call. And I guess with that, we'll go ahead and wrap it up, and I'll be posting this on YouTube as soon as I get it processed and rendered and everything. So, good night, everybody.
Take care, everybody.
Good night, and thank you, guys.
It's different. You know, I get a lot of feedback from a lot of people, positive and negative. And, you know, there's always somebody trying to debunk something that, you know, that they're not even really qualified to discuss, but,
Yeah, well,
which is, you know, pretty common. But one, you know, probably the most common one is, well, if you're taking energy from the transformer and if you're able to power an incandescent bulb with it, how can there be anything left to be able to charge a cap and feed it back?
that's the magic of the switching.
And that seems to be the most common thing. And you kind of mentioned one analogy, Jim, to
Yeah, well, there's a very old demonstration in physics where they use a thing called a ballistic pendulum. But rather than get into the complexities of that, I just simplify it even more and talk about firing a high-powered rifle into a tree. If the bullet doesn't come out the other side, it means it's surrendered all of its energy to the tree. If it goes through the tree and keeps on going, that means it had more kinetic energy. It wasn't removed from the bullet. And that's exactly what happens in an electrical circuit. If you pass a current through a resistive element and the current keeps flowing, what does that tell you? If this person's theory was correct about there not being any energy left, then not only would the light go out, but your current would stop flowing for a period of time until you reverse the cycle, and that certainly isn't what happens.
So it's kind of like an electrical version of mass moving with inertia. Is that similar?
You hit a very interesting parallel there, because one of the things that has not come down to us through electrical physics was the work done by Tesla in this regard, and he talked about the great importance associated with electrical momentum. And that was explored by Einstein and de Haas back in the 20s, and they came to the conclusion that there were aspects of Maxwell's equations which did not identify the component of energy associated with mechanical motion of the conductors. I mean, the conductive particles. And so that's been left out and it's never been fixed. And that's only part of it, but you know, there's plenty of room for the effect. Just keep in mind that if it was really against nature, we wouldn't be doing it.
Right.
Well, and that everything we do is no laws of electrical physics. We haven't changed a thing. We haven't created any new formulas, new known ways that electricity works. We just took electrical switching to make electricity work multiple times. You know, instead of letting that electricity rotate around just through the, you know, one terminal through the load back to the other, we
Interrupt the process.
interrupt the process and capture a charge, and then make that, and where we got work out of that charge once, well, then we turn around through the switching process and make it work through the load again while it creates a cancellation force within the supply. You know,
Hi, everybody. This is Aaron Murakami, and I'd like to welcome you all to the call. This is the live Q&A session that I have set up with Jim Murray and Paul Babcock. The reason if you received an invitation to this call, it's because you, in the last couple months, have purchased a copy of the presentation from the recent 2014 Energy Science and Technology Conference. And the title of the presentation is The Secrets of Tesla's Power Magnification. And at the conference, not only did Paul and Jim give a co-presentation on that subject, but they also had a demonstration of Jim's SERPS technology using Paul Babcock's switching technology. And at the conference, what everybody was able to see was a demo where 50 watts of light bulbs were being lit up to full brightness, yet there was only 1 net watt of power drawn from the power supply. So that doesn't mean 1 watt is lighting 50 watts of bulbs. It means by the time you take some energy and give it back, the net that was taken from the power supply is 1 watt. So there is a difference. And first of all, I'd like to thank Paul and Jim for being on the call with us tonight. They've been putting in a lot of long hours working every day on their own developments with some of this technology. And so, you know, coming to the end of a workday, it's kind of late for them. So I'd like to thank them for taking time out of their schedule to be able to be on this call and answer some questions. And before we take some questions live from the audience, there's a couple things we'd like to go over. And I'd just like to mention, if you can go ahead and mute out your phones, and then here in just a bit, I'll go ahead and open up for questions. So one of the first things I'd like to mention is that, Jim, you had something to say about the kind of the patent situation, and there's a lot of people, you know, asking very specific questions about the circuitry. And so if you'd like to go ahead and start off by addressing that.
Yeah, sure. Basically what the message is that I want to deliver is a very simple one. We have been working on this for many years. Paul and I were, of course, doing separate things and came together only about 2 years ago, but now we're working together to get this thing to the point where it's going to be commercialized. And so one of the first things that's necessary in that regard is to file for patents, and we have done this. And the fact that we made a superficial disclosure during the energy conference is going to present us with enough difficulties in getting around the patent office, who is always trying to stymie these things. And so it would be a great help to us if you'd be patient and understanding about the fact that we can't reveal everything that'll make this thing work at this point in time. However, you should also be encouraged about the fact that ultimately this will be in the public domain. We have no intentions of us by building my own instruments. And I'm not about to go into a 2-hour lecture on how to do that, so he's just going to have to be patient.
Okay.
Yeah, the other thing is you have to think about electricity different. This is not resonance. It is in a way, but it's really because the switching is what we call pure switching. You know, it duplicates mechanical switching. You're really interrupting any resonance. You've divided your sine wave up into really what you're doing is charging and discharging in DC form out of AC waves. So it's not, you can't think of it in terms of resonant as standard resonance. It will drive you crazy if you do so.
It's actually the type of resonance that they find in a cyclotron. It's called temporal resonance. And even though there's elements of impedance matching and the use of tank circuits involved in the overall picture, it doesn't come together the same way. So in that regard, Paul is absolutely correct, and you should take note of that.
From experiments, an audio amp or an inverter as a source can't recycle the energy that's sent back, as opposed to a mechanical generator with moving magnets. In your opinion, can this be done with a solid state source?
Inverters are, you know, it's a great way to burn up an inverter because you know, when you use a transformer, you're actually sending that power back to the grid. It's very hard to measure because of how the grid works, because you have this massive 0 ohm load out there. But on a generator, what you're trying to do is create motive force, not drag force, to cancel out the drag force. You know, you have Lenz's law in a generator. The more current you draw, the more horsepower you have to expend to overcome the drag in the generator. So what you're really doing is you're taking power out, you're making it work, you're storing it, and then you're putting it right back in at the right point that forces that generator to turn into a motor, but you're still making work both directions. So you're trying to reduce drag force on your prime mover while you're creating work at the same time. And that's the mathematical inequality. And so that's the trick to the timing. And your switching has to be clean. You have to basically duplicate mechanical switching. When you're putting just standard transistors in there with the bypass diodes and all that, you get sneak pass through and forth, and that's why if you go look at the flyback patents that are published, you can see some of our architectures that will allow you to do that.
Okay, and I can maybe post some links, I don't know, since they're in the patent database,
Yeah,
pretty much everybody can look them up.
yeah, you know, and that's public knowledge, and you know, anybody can look up our patents. They've been out there for years, so I wouldn't tell anybody that that's how we do our switching. It's a big dark secret anymore.
Uh-huh. Okay. Now in terms of, you know, thinking about
It's
electricity.
on three-phase. If he's got a three-phase machine, he's gonna have his hands full. I'm not prepared to talk about the three-phase stuff because we've only now entered into single-phase patenting. But I will tell you this, in the long run, to depart from the norm in generator design by having some kind of an unusual arrangement with all north poles, that's going to make your job a lot more difficult. If I was doing it, I would start with a very traditional machine. We'll leave it at that.
Another thing is if you're dealing with European power, the difference between European power and American power is you don't have neutral 120, 240. All the power is the same. And you really need to work with a center tap secondary transformer to get started. You know, it's part of the trick to putting the power back. And so if you have a 50 cycle transformer that's single phase that you can plug into the 230 or 240 and then voltage and get a center tap, split phase, secondary output, that's what you really need to develop your circuitry.
Another part of this question is, I have more questions regarding the switching timing, which I'll post, but this is the most urgent one for me to advance since I'm putting the new setup together. I guess you kind of already addressed this. If you tell me 2 phases won't work, that'll save me some time, and I'll try to locate a single phase generator. I suppose it has to be a generator with magnets though, correct? So
Not necessarily, it's,
actually easier the other way, to be honest.
yeah.
yeah.
The thing about your generator is it's got to have a quality sine wave.
Okay.
Don't go buy a cheap Chinese generator, it'll break your heart.
And you've already answered pretty much, start with the transformer, not the generator, because it's going to be a lot easier to go that route. Let's see. Now he's asking some specifics on the circuits, and as you've already mentioned with the patent, there's only so much you can say right now until that's published. But where exactly do you switch with respect to the source sine wave?
That's proprietary, we're not going there.
Okay. Let's see. If we were to mimic a tank circuit with a load in series between cap and coil, we could only have some success if the source voltage would be very high and the impedance resistance of the load would be very low. I imagine this concept to be true for the SERPS process as well. Is this correct?
He's getting into some sticky territory there because the question itself suggests that he doesn't know the difference between EMF and voltage. A tank circuit is a voltage sensitive device with respect to the voltage drop across the inductance and the capacitance. If he starts doing this in a generator, he's going to have to be in the position to differentiate between the EMF in the generator winding and the voltage in the generator winding. And there are no known instruments that do this. And so the way I conquered it was keeping it a secret. We just would be very grateful if you wouldn't start passing information all over the internet about this thing, because it's going to be a difficult thing to get a patent granted on a subject as obtuse as this one to begin with. And if you muddy the waters by circulating all kinds of theories about how it works and how it doesn't work, that makes our job a lot more difficult. But I do encourage you to continue your personal investigations. Just keep a lot of what you're doing to yourselves, and eventually it'll all be vindicated, because I guarantee you this device is real.
Now there's, asked a few people to go ahead and post some questions in Energetic Forum in the thread that I started when I released that first demonstration video showing the 20 times more on the SERPS demo. That's when you're heating up those inductive resistors, showing about 100 watts for only a few watts being drawn from it. And obviously anything like this, there's going to be a lot of skeptics coming out of the woodwork and trying to debunk everything, even though they have no idea what their circuitry actually is. And but thankfully, there are some people, that obviously they see the possibility here, and from what they learned from the presentation, in principle, everything you guys are talking about makes sense. And so there are a couple questions here that I just want to cover from somebody named Mario. He's in, I believe he's in Switzerland or something like that, wasn't able to join the call. So I'd like to at least answer his questions that he posted in the forum. And then I guess after that we can go ahead and open up for some live questions.
Sure, whatever you want.
Okay. So for Mario, let's see, he posted this on, looks like fairly recently. One of them was today. Okay. So thanks for the opportunity to dig deeper into this. Since the release of the video, I've been working on this quite a lot. First, an audio amp as a source, then with a motor-driven generator that has the magnets north only facing the coils, which still gives an almost perfect sine wave. This may or may not be ideal. I just got a 1 kW 3-phase neodymium wind generator to make further tests on, but the 3 coils are star connected and I can't access the neutral. Should the SERPS effect still work if applied between 2 phases as a source, which gives me a sine wave, which is the result of the vector sum of the 2 sine waves? Or do I have to have access to 1 coil terminal to do the switching on? That's one part of it. Do you want to answer that?
Yeah, I'll take a stab at that for you. First of all, the best advice I could give this gentleman would be to concentrate on using a transformer as a source initially. It's a lot more difficult to achieve this effect than what you think, and to do it, in an effective manner. Secondly, when it comes to generators, there's going to be a very complicated arrangement necessary to access this